Welcome everybody to this session about integrating SAP S/4HANA into SAP Data Hub. We provide you an overview and show you some use cases and some demos. My name is Britta Thoelking. I'm a product manager within SAP Data Hub, and I'm also product manager for SAP LT Replication Server, which we will also talk about in this session today. And with me is Tobias Karpstein. He is the area product owner of the whole ABAP Integration, so anything that deals with communicating, interacting with ABAP-based systems towards SAP Data Hub is within Tobias' area of responsibility. From an agenda point of view, what we have planned are basically 3 parts. We'll give you a very brief overview about SAP Data Hub, just to bring everybody on the same page. Then we will, in a second part, deep dive into this ABAP integration topic. Tobias will take care of that. We will show you some predefined ABAP operators that we deliver in SAP Data Hub and how you can work with them in your data pipelines. And in a third section, we will then talk about SLT. SLT plays an important role when it comes to the ABAP integration and how this SLT it's another product, yeah? It's a replication engine. How this SAP product interacts here in the whole scenario, we will show you then in the third part. Okay, coming to SAP Data Hub. So SAP Data Hub and SAP Data Intelligence, by the way, it's for now, please imagine it as the same product. SAP Data Hub is our solution for data orchestration. So we offer here different services that help you to overcome challenges that you typically face when you deal with very heterogeneous data, system landscapes. And when you want to move data, bring data together in such a landscape, join in the end, gain insight out of your data. And when I talk about heterogeneous landscape, I'm referring to what you can see here also on the slide on the left and right side. So on the left side, we are focusing more on the SAP world. So we see SAP S/4HANA systems. You might have on-prem systems. You might even have a cloud system. It's about ERP systems, about BW systems, SAP HANA boxes, some cloud solutions probably like Fieldglass or Employee Central and so on. And then on the left side, what is more like the external world for us, distributed systems, HDFS, the Hadoop ecosystem, some messaging technologies maybe like Kafka, which is coming more and we see in more and more landscapes. But also cloud storages and third-party applications, maybe third-party databases, Oracle, MS SQL, and so on and so on. And whenever you have like scenarios where you want to work with data spread throughout this landscape, we support you here in different manners. And the core functionalities of SAP Data Hub are summarized here in these 3 buckets in the center of the slide. That's first of all data pipelining and processing. So this is about mainly about the Data Hub modeler application that allows you to build your own data pipelines. A data pipeline you can imagine like a data flow throughout your landscape. You have operators that you can connect to each other and that make up in the end a data pipeline. And each of these operators you can encapsulate a certain logic that you want to execute. You can decide whether you want to execute the logic in the remote system, which means you can let the data reside where it is. However, depending on your use case, you can also bring the data to Data Hub, execute the logic there. You can decide whether you want to reuse pre-delivered operators by us. There are a couple of hundred of operators that we offer at the moment, and we are enhancing this with every release. Or you can also come up and implement your custom operator in a language that you prefer, JavaScript, Python, and so on. You can also bring your own language, deploy it in Data Hub, and write then your custom operator. So you are very flexible here. By the way, SAP Data Hub is runs on Kubernetes. So typically, this is now oversimplified, but typically one operator runs in his own Docker image. So you're also here very flexible because you can scale up. So if you have a very expensive operation that you want to execute within this operator, you can parallelize a lot So this is really pretty cool and opens up lots of new possibilities. Secondly, it's about data orchestration and monitoring. So we help you also to monitor your running data pipelines. You can see like how many processes are assigned to a running pipeline, how is the status of my pipeline, is everything running good or not. You get some like logs, error messages and so on, so that you do not have to necessarily log on into all the remote systems, but you get a glimpse already from SAP Data Hub. Of course, there's also a centralized connection management, and connections that have been created once to remote systems can be reused in other applications within Data Hub, of course, and so on. And thirdly, it's about data governance. And this means for us mainly the functionalities that we offer within the metadata browser of SAP Data Hub. So this is an application. It allows you to connect to your systems, browse the data that is there, get to know what data is it, what kind of structure is it, what kind of columns do I have, what are the data types, how is the quality of my data, do I have lots of duplicate values that I want maybe to cleanse. So also here we have some built-in functionalities to prepare your data, and it's also about lineage. So imagine a CDS view. It bases on a lot of tables. Some CDS views even consist of hierarchies of CDS views. So we want to keep this information, how the CDS view is built, the semantics of the CDS view, and show it to you in the metadata browser. All this functionality support you in the end-to-end process of realizing these data flows and guaranteeing data integration. I mentioned SAP Data Hub and SAP Data Intelligence. You might have heard of both. Basically, Data Intelligence contains this functionality that I just introduced, what is part of SAP Data Hub, but on top, Data Intelligence includes also machine learning services. And also the deployment is a little bit different. So Data Hub, you deploy either on-premise or in a public cloud environment, whereas SAP Data Intelligence is offered as a fully managed service on SAP Cloud Platform. But we plan here to align the names because basically it's the same product. It's just a current intermediate state that marketing did to us. But if we mention later SAP Data Hub, the same is true for SAP Data Intelligence. So don't be irritated by that. So this session focuses now on the upper left corner, ABAP Integration. So any interaction that deals with S4 systems, especially here today in focus, but also ERP systems or BW systems. And as I mentioned SLT also in the beginning, let me spend another minute on clarifying here a little bit how things come together. So if we want to interact with an SAP S/4HANA system of release 1909 from SAP Data Hub, we need an SAP Data Hub 2.7 release, and we can then communicate with the system via the ABAP integration directly. This is what we just released last month in September, and anything that deals with SAP systems of a lower release, like an S4 system 1809 or an ERP system, we realize via SLT. So we have built here a tight integration, SLT to SAP Data Hub. We can externally control SLT, start, for instance, a table replication via SLT to Data Hub. And in that manner, we can also consume business data out of SAP systems of older releases. Not only from a technical point of view, we tightly integrated, but also from a licensing point of view. So if you purchase a SAP Data Hub license or a DI license, SLT is included. Handing over to Tobias.
Okay, thank you, Britta. So now we want to have a closer look at the ABAP integration itself, how that is handled. Britta was mentioning that Data Hub itself is running on a Kubernetes infrastructure, so you have individual pods taking care of the different operators of the different execution stacks. And how can we make that work with an ABAP environment where you obviously do not run on a Kubernetes cluster and you do not have pods? So everything looks a little bit different in ABAP, right? So once coming back, the main idea is that we want to connect the SAP Data Hub with S4 systems in the cloud, business warehouses as well as business suite systems. So the ABAP integration itself will go down to a basis 700, while with the SLT connector we can even support 620 or 46C environments, so really all the way to the old school ABAP environments. This lecture will mainly focus on the data provisioning, so loading data into the Data Hub, as well as triggering functionality from Data Hub within the ABAP environment. So imagine you have your Twitter streams, your Facebook streams, you combine that data with your structured data in ABAP, you run your machine learning algorithms and you identify some important facts and you want to act on that. You can fully automate that by calling the respective APIs in the ABAP environment and therefore trigger follow-up activities. There's one more dimension to the ABAP integration, which is metadata. We are not taking care of that in that lecture because there is a dedicated session, .162, if you're interested in that. So how does the integration from a repository perspective look like? You have on the one hand side the ABAP system, you have the pipeline engine inside of there, and the pipeline engine is, so to say, yet another sub-engine of the Data Hub main engine. Britta mentioned that before, that you can, in Data Hub, create operators in different languages. Python, Go, C++, Node.js, and so on. All of those languages represent a unique sub-engine. And what we are now introducing in September this year, and so just 1 month back, is also a ABAP sub-engine. But in contrast to all the other sub-engines, it's not located inside of the Data Hub, but it is shipped, or it is made available inside of the ABAP system, inside of the connected ABAP environment. And it will contain pre-delivered operators. So the coding of those operators will also rely in the ABAP system. We will not, and we will also not in the future, allow code injection from Data Hub into your productive environment. So that is completely isolated from each other. While on the other hand, all your modeling is happening in Data Hub. That means we are loading the necessary metadata information of how does an operator look like, what are my imports, what are my outports, what is the name of the operator, what's the documentation of the operator, so that others know how to use it. We will make that available in Data Hub so that you can model your graph, your pipeline end-to-end in Data Hub, and it may contain operators in different languages representing different subgraphs, and one or even many of those subgraphs will represent an ABAP operator or multiple ABAP operators linked to each other. And if we now go further and look also at the runtime, not just the design time, so you can imagine that basically as the design time. The real coding artifacts are shipped via ABAP. Your modeling is done in Data Hub. And if we now come to the execution of such a graph, you will execute such a graph in the Data Hub, and it will start the main engine, plus all the other sub-engines which might be involved, plus the ABAP sub-engine in case there is ABAP operators, in case there are ABAP operators involved. In that case, it would mean it is opening a connection to the ABAP system and therefore spinning up the ABAP pipeline engine there. And the real execution, in that case, it is reading a CDS view, will happen in the connected ABAP environment. So there the operator is being executed. While from a Data Hub perspective, all the monitoring is there, and you suspend, you resume, you start, you stop the graph. The data which is in that example being fetched from the CDS view is in that case transferred back to Data Hub and handed over to other operators. In that example, and we will have a demo on exactly that in a minute, it is being written into an S3 bucket on Amazon S3. But you could replace the file writer with any other kind of operator so that you have a CTS Reader into a Kafka producer, or into a Google BigQuery, or into an Azure object store, basically whatever you want. So that is here the flexibility and the freedom which is coming with Data Hub. So that is then basically the runtime. So it is a combination of several pods being running in the Kubernetes environment of Data Hub, plus dialog work process in the traditional S4 or ECC environment. Now a short introduction to how that is being shipped. So with S4HANA 1909 as well as with S4HANA Cloud 1911, the ABAP pipeline engine is included. Below 1909, so in 1809, that is not available. While on Business Suite environment, and it is part of the code line of S4HANA, so no need to apply any additional add-on or whatsoever. While in the ECC world, the only option we have is to use a add-on to ship our coding. And that add-on is the DEMOS add-on. It's a non-modifying add-on. It's the very same add-on. The product SLT is being shipped. So if you want to, for example, use a combination of ABAP integration with SLT, it's anyway only one add-on which you need to install. And that is being made available down to 700 NetWeavers with the ABAP integration. So that is basically the requirement to make that scenario work. And on the Data Hub side, it's the Data Hub 2.7, respectively Data Intelligence 1909. I mentioned there are certain operators pre-delivered. What are those? On the one hand side, on S4 code lines, that's the CTS Reader operator. It allows to do an initial load as well as delta tracking on any changes of any of the tables participating in a CDS view. It is materializing those CDS views and is then sending them to Data Hub. So you can, in contrast, for example, if you know SLT from the past where you have a table-based replication, it's the same for SDI. You stick on tables. Here, the difference is that you can actually model, or you can use models shipped by SAP, which represent a semantically richer data entity compared to just a table. In that case, a CDS view. Another pre-shipped operator, or basically the flexibility to also create custom-owned operators, is what we call the custom ABAP operator. We defined a body interface in the ABAP system, which is being shipped and which can be used by any partner, customer, or freelancer to implement custom-specific logic. And it's completely free what you use there. I mean, obviously, you need to use ABAP, but you can use any kind of classes. You can call any kind of APIs, function modules. You can even submit reports to execute the logic you're intending to execute there. You can combine also those operators, obviously, with other operators in Data Hub. And last but not least, what is pre-shipped is the SLT connector. So it allows you to basically stream the data which was recorded by SLT into Data Hub to further process them. That's, I think, especially powerful if you want to connect to targets SLT are not natively supporting, like object stores, for example. So in that case, you can let SLT stream into Data Hub, and Data Hub further stream into, I don't know, into Kafka, into S3, and so on. We will also show that in a minute in one of the demos. Good to know. The ABAP CDS view replication is only available starting with 1909 on-premise and 1911 in the cloud. The S4HANA Cloud does not allow custom code, therefore a custom ABAP operator does not exist. So if there are use cases which are not covered by the pre-delivered operators, and I'm pretty sure there are some, then we just need customer feedback. What are those use cases which we need to cover from our end? And with the SLT connector, as mentioned before, it's also possible to connect to systems even on releases lower than 700. SLT allows you to connect to 620, for example. Therefore, in a 3-tier setup, you can connect, let SLT connect to a lower release than 700, as long as the SLT server is at least on 700. Therefore, you can also have an extraction graph from 620 via your 700 environment into Data Hub and further stream wherever you want. Now having a little closer look at the CTS Reader operator. ABAP CDS views are basically the chosen entity in S4 to model business objects. You can stack the CDS views, you can combine multiple tables, you can assign annotations to the CDS view to make it a more richer representation of the data, to add further information to it. So typically, if we look at the CDS view, it consumes or it joins multiple tables. And what we now invested into, and that is exactly what the ABAP CTS Reader operator is utilizing, is a change data capture mechanism which will track changes on each and every individual table participating in one of those CDS views. And we will take all those change pointers which have been recorded by the change data capture engine to reconstruct a materialization of that specific tuple of the CDS view, which we will then send out. So what we are sending out is basically the materialization of the CDS view, which changed by one or many operations on one of the tables. And yeah, as illustrated on the picture, that can then further be pushed to any kind of target. And having said that, I would say let's have a quick look into the systems, not just PowerPoint slides, and have a look how that looks like. So this is basically the launchpad of Data Hub. You have different applications running in it, just refreshing. And what I would like to open is the modeler. So inside of the modeler, you can have a look at all the operators and create your own graphs. So now it's still loading. So, okay, so we have, as you can see, we have the graphs open and we are already pre-selecting only for ABAP things. So if we would like to see all, there are way more graphs available and pre-shipped than just the ABAP stuff. But for now, we are good with the ABAP stuff. And if we now open, for example, the test, no, that's the test custom. I wanted to open the test CDS. Those are, in that example, 3 operators linked to each other. And you can also see that the out port of the beforehand operator is linked to the import of the operator next. That allows us to also have language switches in between the operators. As you can imagine, the first 2 operators here are in ABAP, while the last one, I think, is written in Go, for example. So if we have a closer look how to customize one of those operators, so the label, we could change to whatever we want, right? That's just text being displayed here. That's probably not very useful, but in theory possible. You need to choose the action which you want to use. R here stands for replication, so it's doing an initial load of the CDS view and is listening to changes on any of the tables below. And you need to specify the CDS view itself, as well as specifying to which ABAP system do I want to connect to. You can always have a look, for example, at that in a JSON representation as well. You can also do all the adjustments here if you prefer that. Most users, I think especially for simple graphs, are sticking to the UI representation of the same. The converter takes the ABAP representation of the data and converts that into a JSON representation, or in that case, for example, a CSV representation. As we later on want to write it as a file, we choose here CSV. And last but not least, the file writer. As you can see, you can choose between different stores. In that example, we are using the S3, and you have to select one bucket as well as the file path. In that example, ABAP TA12, that's my username I'm logged on to, and so on. Just to make sure that there's nothing in that S3 bucket at the moment, I can refresh here and go down that path. So ABAP TA12, and right now there is one file rating. We need that in a minute, but nothing else. And if I now save and execute that CTS Reader graph, what we should see is that graph being pending. That means it's spinning up now all the pods in that Kubernetes environment, invoking in the ABAP system the respective ABAP pipeline engine. And once it's done with those, let's say, ramp-up activities, it will the graph will run all the time. And as you cannot see any termination operator, that is one example of a graph which will run indefinitely. Simply because if you do a replication, you never know when new data is being populated, which you need to replicate, right? It is now running. It's indicating that it's running. So what we can do, we can refresh in our S3 bucket, and we can really see CDS rating. That is the CDS view which we replicated, and we can have a look. I mean, there's only an example. There's very limited data in that case 3 records, and they are column separated, and there are some, let's say, ratings on those different airlines which are being stored in that file. Yeah, that was the first demo. If there are no questions to that, I would continue with the custom ABAP operator, and after that we would come back to the CTS Reader real quick to see how the replication looks like. So, custom ABAP operator, exactly. So, as mentioned before, this is the possibility for customers, partners, anybody basically to create own operators, not just in Data Hub, but now also in ABAP. We are making use of the body concept which exists in ABAP, which basically defines an interface with several methods which needs to be implemented. You need to tell what is the name of the operator, what kind of imports, what kind of outports the operator shall have, and of course the body of the operator, so what kind of logic shall that operator run through. Once you've done that and you choose the custom ABAP operator in the Data Hub system and you connect to that system, that operator will now become visible in a drop-down box. So you can choose that operator, and you will implicitly get all the imports, all the outports in your modular UI. And yeah, as mentioned, you could even combine that and have a pipeline first reading a CDS view, doing some transformations, calculating some results with a machine learning algorithm, and take those results and bring it back into the ABAP system via such a custom operator, calling some API to trigger some follow-up processes. Just one example. I mean, you have any freedom as you can create your own code with that custom operator. And that was real quick. I would like to show what the custom ABAP operator is doing. So what we would, I have it open here already. So let's have a quick look at the graph. Now we have a file reader instead of a file writer. It's going as well to S3. It's going to bucket 1. And as we can see, it is using ABAP TA12 rating CSV. So it's now reading the file which already existed in that S3 bucket. It would hand it over to the operator. In that case, it will basically make updates to the tables underneath of the CDS view, which we just replicated. And remember, we have not yet stopped, right? So what I would expect if we run that graph, which is now posting information into ABAP, that the other graph will auto-detect that something changed and therefore auto-replicate the changes to the file in the S3 bucket. Here, as that is not a endless process, but rather, let's say, a one-time read a file and process it, we also have a graph terminator. So once that's done, we will end the process. So we can start that as well. So we will see that now pending. As mentioned, it's spinning up now the pods and so on. And once done, we'll read the file. Maybe in the meantime, we can have a look at the rating CSV file. What's in there? Well, that's pretty small, I guess. So for the different airlines, you have now ratings, just indicated between 1 and 6, different numbers. I think several hundred, which we have here. It will take them, and it will run through some algorithm in the ABAP system to update what's the overall rating of those different airlines based on, I mean, we are simulating here feedback from the customers, right? Yeah, so by now, hopefully, it's completed already. So as mentioned, it will auto-complete once done. So what we can do now, because the CDS graph was running all the time and still is running, we can also now have a look at the CDS ratings once more, maybe update. Have a look that we really now, what I would expect as we have been chosen append instead of override, is that we see more records. And yes, indeed, that is the case. besides the first 3 records, which were initially loaded, we now also see delta records, which have been reconstructed in the source system and respectively pushed into that bucket file. And you can also see that because we indicate that with that U, which means that's an update. You could also see inserts or deletes. But as we have been updating one of the tables, it's now an update on the CDS view. So this is basically what I wanted to show with those 2 small demos. If there is no further question, I would hand over back to Britta for the SLT part.
Yeah, so coming now to our third scenario that we want to show here today, how we integrate with SLT. I would first of all give a quick intro to SLT. Who of you is familiar with SLT? Okay. Okay, so even much more people. Cool. Good, then I think this is pretty interesting for you. So SLT is positioned for real-time trigger-based data replication from ABAP-based systems mainly, also from non-ABAP-based systems, into various target systems, and most prominently to SAP HANA. This is like the first use case that we had with SLT many years back. It's allowing delta replication. The delta is being fetched by a trigger change data capturing mechanism. We put database triggers to the tables that we want to replicate with SLT, and they capture any insert, update, or delete operation, put it into or store the information in a logging table, and the SLT then checks for the logging table and takes out the delta records to the target. That's the idea of SLT. If you're familiar with SLT, you might also remember this slide. So we keep it for a long time now, and with every release, or not maybe with every, but it tends to grow and grow. So you see a couple of source systems that we support on the left side, a couple of target systems. So the source side is very SAP-centric. So we have SAP Business Suite, S/4HANA systems, but also databases like SAP HANA or third-party databases like SAP ASE, Oracle, MS SQL, and so on. So basically here we support anything that is supported by NetWeaver and SAP Cloud Platform and S/4HANA Cloud System. On the target side, as I said, most prominently it's SAP HANA that we replicate to with SLT, but also central finance, for instance. So if you want to run a central finance system in your landscape, SLT is the set middleware technology to get all your FI, CO-related data into central finance. Also for the replication to BW, we use SLT a lot via the ODP or directly in case it is and BW for HANA system, we directly replicate into the underlying HANA database of BW. And by means of an RFC connection, we can also replicate to SAP systems. And what is quite new is SAP Data Hub, of course. So, and this in 2 senses. So we can replicate to SAP Vora by means of a database connection. Vora is the persistency of SAP Data Hub, but we can also replicate into a Data Hub pipeline or a Data Hub graph. And this is what I show you also in a minute. To that, yeah, maybe from an architecture point of view, SLT is deployed on a NetWeaver system, typically. This means you have a NetWeaver system and you install the DEMOS add-on, what Tobias just explained. Then we have a source system. If this is an SAP system, you also need for this system the DEMOS add-on because it contains a read engine that takes care of all this change data capturing mechanism what I just mentioned. And yeah, that's what you need from an installation point of view. SLT and SAP Data Hub and the value proposition. So what you saw in the first demo was how we get CDS views, either as an initial load or even based on delta records, how we get the data into SAP Data Hub. SLT is now playing a role if you want to extract a business data based on tables into SAP Data Hub. So, and from SAP Data Hub point of view, this makes a lot of sense because we have this proven technology, which is out there since many, many years. We have more than 8,000 customers that are quite satisfied with the tool, and yeah, we just reuse here the technology that we have available within SLT, and also from the other point of view, from SLT point of view, if you are a customer that has already a SLT footprint, you might have your replication scenarios to HANA, to BW, to central finance already in your landscape. You can easily extend your investment here. Yeah? You can use your same SLT box, your same SLT server, you just add another configuration or another couple of configurations towards SAP Data Hub, and now you can finally replicate with the same technology, with using the same CDC as always, but you can now also replicate your data to Kafka, for instance, or to a cloud storage. So anything that so far it did not support. And we also do not plan to support. This is also why we have here this combined session to show also where SLT's future is going to. We are also from an organizational point of view moving more and more together. So we are one team here, SAP Data Hub, SLT, also other EIM technologies like SDI, SDA, or data services. And this is where the future goes to more and more integrate also with the Data Hub platform. Exactly. Realized in the end is this within Data Hub modeler with the SLT connector operator. And in the remote system, we have SLT either as part of the productive source system or as a separate instance. So this depends on maybe how your landscape at the moment looks like. So if you have already a separate SLT instance, I would go for that one. If you do not yet have SLT in your landscape, you might just want to run SLT as part of your S4 system, which is possible. No installation required. We heard that already. Just SLT is contained in the core of S4. So, and this is exactly also the scenario that is shown on this slide. So we have SLT as part of the S4 system or the SAP Business Suite system. We have this database triggers and logging tables, so the CDC engine of SLT. And we can do table replications to SAP Data Hub pipeline. And this is now the moment where I want to show you the exactly same thing in the system. So we are going now back to our modeler. We have also, for this scenario, a prepared pipeline already. It looks very similar to the CTS view extraction. We have the SLT connector operator. This is an operator that can communicate and also trigger a remote SLT, can communicate to a remote SLT and also triggers a replication remotely. From a configuration point of view, what we need to provide is a mass transfer ID. So you might know that in case you have worked with SLT already, the mass transfer ID within SLT is basically a definition of a source and a target connection within SLT. So if we log on to the ABAP system and we enter transaction, the system has gone. Let me try to log in again. Okay, good. It was just network issue probably. Yeah, if you enter transaction LTRC, what I just did, you enter the SLT cockpit. You have here a list of different SLT configurations. Yeah? So as I said, a configuration is a combination of a source connection from SLT to a target connection. For the purpose of this demo, we connect to the source system, which is the exactly same system. So we put like an RFC a dummy RFC connection to the same system. And towards the target, we connect to SAP Data Hub. So I can also quickly demo how and create a new one, like test SLT config. I provide a name for this configuration. The RFC connection, in this case, I can just enter none because I want to extract data from the exactly same system. And then for the target system connection, under this option other, I can simply specify SAP Data Hub as a target. And then I'm asked here to provide some job settings, and I can create a configuration. So that's actually the only prerequisite that I need within the SLT at the moment. there are plans, of course, to also automate and orchestrate this step, so that ideally in the end you are only working in the SAP Data Hub modeler and anything is created out of the box for you remotely. But in the version that is delivered, that has been delivered last month, this is the case, how you see it at the moment. Okay, so let's take this demo SLT configuration. It is identified by a mass transfer ID, OOC in that case. So this is the first thing that we need to specify in our SLT connector operator. And the second thing is a table, of course. This is a copy of a sFlight table, ZSFlight_12, and we need to specify a connection to the remote ABAP system. And this ABAP RFC is a predefined connection that has been created in the connection management before, so we are just reusing it, and it points exactly to this ALX system. Yeah, so then we have again the ABAP converter, as we saw before, converting the string, converting the SLT connector output to a string that we can then write to a S3 file. And also here, the write file operator is specified exactly in the same way as Tobias showed you before. So we are writing in the same folder on this S3 bucket 1. Yeah, so this is actually the whole magic. When we now save that and execute it, what will happen is that this data pipeline is triggering an SLT table replication. Let me do that now. So again, also here, we need a couple of seconds until the pipeline is running. What you will see in the moment the pipeline is running, and if you know SLT, you will be familiar with this UI here. There will be this one table will pop up here in the table overview. You will see how SLT is processing the initial load and the delta replication of the table. It is calculating the table, it's creating a logging table, it's creating the triggers, so you can monitor the process here, as you know from maybe other replication scenarios. Now it is running, so refreshing this here, you see, okay, there has been a logging table created for this table. Also the definition, generation, calculation, and so on has already happened. It went really fast. An initial load is even completed, and this table is already now in replication. Let's have a very quick look at how the table looks like in the ABAP system. So this is the data in the ABAP system. We have 15 records, some flight dates, and when we go now to our browser, refresh that one, we have a new CSV file. We can download that, and we should see these 15 records also here. Yeah, wonderful, looks pretty good. And now let's quickly demonstrate also some deltas. Therefore, I have prepared a set report. Yeah, that is adding or deleting data records in our table. So let's quickly enter some dummy data here, giving a flight date, a certain price, a currency, and so on. So this is the flight that I want to now insert. I'll execute that report, and it has been inserted. And now refreshing our browser here, we should see an update. Yeah, looks good. We download the object, and now we should see an additional record. This one in line 16, and it looks similar like before for the CTS view. In this case, we have an I at the end of the record, which means that this record has been inserted. And I think this is very good and very important here, that we keep the operation, whether it was an insert, update, or delete, because maybe within your data pipeline you want to react on these different events. Yeah? Maybe for deleted records you want a different behavior than for inserted records or so. So this is really opening up here possibilities. Yeah, so that's it for the SLT connector. Yeah, I mentioned that already briefly. There are different deployment options. So also a little bit depending on how your landscape looks like at the moment and what you want to do with the business data that you are extracting via SLT. So is it just that you have so far no touch points with SLT and you want to have like 20 tables for 1 or 2 data pipelines because you want to do some data science with the data and merge it with some social media data or some sensor data, and it's just like 5 to 20 tables or so, then probably it's the best option to let SLT run within the productive source system. However, if you're really going for masses of data and you have already SLT footprint, already SLT system in your landscape, other replication scenarios, most sense makes usually to have SLT on a separate system, because then you can isolate the load that is caused by the data transfer jobs from your productive systems. And this would be then the last option that you see here. Another advantage of that is that you can also extract business data out of SAP systems of a really low release. So SLT supports down to 4.6C systems. So anything in that area can be connected via SLT. Looking a little bit into the future, so we had now 3 operators: CTS Reader, Custom ABAP Operator, and SLT Connector. What we also want to offer is a table reader operator that goes directly to the source without the need of going via SLT. This is coming. However, this will then also be not available for low releases because it requires certain technologies that are only available in the higher NetWeaver releases. That's one thing. And the second thing is an ODP reader operator. So this reader will then read initial and delta data out of ODP. So basically any data object that is supported by ODP can then also be making available within a Data Hub pipeline. So idea or main use case behind that is to get BW data into Data Hub and consume BW data. Yeah, this was basically what we wanted to share with you today. Do you have any questions? Yeah.
I mean, I'm not sure if I'm getting the question correctly, but it will, you will, from a Data Hub perspective, be able to consume ODP, whether that is on an ECC or a BW system, both will be supported.
The CTS Reader, which is actually quite interesting, because we often have issues with the current SLT that you only can replicate one table and only the deltas are coming from that one table. My concern is if you have 100 million sales order items in your table and you join that to material master to get material group, if you're changing a material group, will you then get a lot of deltas coming through the CTS Reader into the SLT? Imagine you have billions of records in your MSEC table. Yeah,
it kind of depends. I mean, it could happen. It kind of depends how that CTS view looks like, how that is being modeled, basically, and how to activate the CTS view. We have not been showing that now because you need to annotate them. You need to tell them basically to participate in that game, data extraction equals activated and so on. And you also have the possibility to tell which tables we should listen to. And you could even specify do not listen to specific columns. So you can fine tune to what we are listening. But if we are listening and it is a very bad cardinality, then you get based on one, I don't know, update 1 million reconstructions, basically.
When to use HANA Cloud Data Integration and when to use Data Hub, right? Yeah.
I mean, CPIDS, for example, right, is now merging into Data Hub. So that is not as a contrary, it's rather enriching Data Hub. And the idea of Data Hub is also not to, let's say, reinvent the wheel each and every time. As you have seen with SLT, the idea is also that it remote controls other tools which are already out there. So besides the fact that CPIDS is now at the moment being containerized to be shipped with Data Hub at some point, it could also be that you still have the implementation as of right now, and Data Hub is just, let's say, allows you to model certain pipelines that way. BW in Data Hub, I mean, the classical BW for HANA, for example, uses the Data Hub to get from different sources data into the BW stack itself. That is also what is currently being discussed if we think about the BW or the data warehouse in the cloud. The data somehow needs to get there, right? And one possibility is to use Data Hub pipelines to also, let's say, make connections. I mean, we are here focusing on ABAP integration, right? But Data Hub can do much more. It can connect to your Twitter streams, Facebook streams, and so on. So you could enrich your warehouse with also non-structured data. And for that purpose, Data Hub is one possibility to do exactly that. On the other hand, with Data Hub, for example, you can model pipelines to do your machine learning algorithms on the data on top, which is, I think, also a slightly different use case from a business warehouse there.
I guess you still have the ability to parallelize your application in LTRS, even though you started from the Data Hub, right? So you can, if you have your enhancements or whatever you do, you create parallelization because you get so many updates that you can make use of whatever you configure in LTRS so that the replication will take that into account.
Very good point. With Data Hub 2.7 right now, so with the September release, that's not yet possible. We don't have a mechanism to parallelize, except of what you can, of course, do is create multiple graphs and use the same, or use, so to say, different instances of a CDS view with different where conditions. But that is obviously not the most convenient way of using that. Therefore, we are working on exactly that. So in the future, we also want to have a UI for the CTS Reader where you can specify a parallelization level, what is my package size. So basically what you have right now in LTRS to remote control that from that UI in Data Hub. And also have parallelization then. Yeah. Yeah.
Do not have add-on.
No.
Because I mean, with 1809, we have some systems which are on 1809, and on that SLT runs without an issue.
Yeah. So on an S4 system, the functionality is always included. It's just the possibility to extract CDS views is only available with 1909.
Okay.
But if you now want to replicate based on tables, data out of an 1809 system, for instance, no installation required. The CDC engine and so on is included there.
Yep.
You can connect the system to SLT, and SLT can push the data to Data Hub.
Okay. Okay. Yeah. Thank you.
Okay. Thank you.